Oops, we're recording. Hi guys, welcome. I'm Mr. Roundy, your wonderful teacher, and I'm here to teach you a little bit about powers and exponents today. So, what do you say we get started? As I just said, powers and exponents is what our lesson's going to be on today. So let's go ahead and take a look at what powers and exponents are. The objective of today's lesson, or our goal, at the end of this lesson, I want you to be able to write and solve expressions that have powers. Now, what is a power? A power is a way to write a numerical expression that has a number that is timesed by itself over and over again. Now, that sounds a little confusing, so let's take a look at an example. Here, I have a numerical expression. If we remember back to the previous lesson that was on order of operations, we'll remember that numerical expressions are a combination of numbers and operations. So here I have a combination. If you're looking at my cursor right here, I have 3, 3, 3, 3. And I have times, times, times. So I have a numerical expression because I have numbers and I have operations. Now you'll see in this particular numerical expression, I have the same number being repeated over and over again, and I'm multiplying it each time. In cases like this, I can use something called a power to make what I'm writing even simpler. If I want to write this particular numerical expression in a way that's much simpler, I can write it with a power. The way I would write it with a power would be 3 with this little teeny 4 up next to it. And that means 3 to the 4th power. But we'll get into that a little bit later. Now, let's look at a little bit of vocabulary that goes along with powers. So, a power has a couple of different parts. It has a base, which is this number, the large 3, and an exponent, which is this smaller 4, if we follow from the example on the previous slide. Both of those put together make up the power. So the whole thing right here is the power. Now, the base is the number being multiplied over and over again. If we remember back to the previous slide, we had 3 times 3 times 3 times 3. And that number, 3, kept getting multiplied. So that is what we call the base. The exponent tells us how many times the number is multiplied. So in this case, I have a 3 being multiplied 4 times. There are 4 3's getting multiplied. When we write a power out, we call it expanded form. So, an example, power form, I would say 5 with this little teeny 3 up here, we'd say 5 to the 3rd power. Or in expanded form, I would write 3 5's, 1, 2, 3, because that's what my exponent says, and I would multiply those together. So 5 is my base, that's the number being multiplied. 3 tells me how many of them there are. 1, 2, 3. So I have power form and I have expanded form. Now let's talk a little bit about how we read powers. Let me write an example here. Let's say we've got 2 with this little teeny 2 up next to it. Now there's a few different ways I can read this. I can say 2 to the 2nd power. That's a common way to read these numbers. However, whenever we have a 2 as the exponent, a lot of times people like to say 2 squared. So whenever we have a 2, we can sometimes just say squared. So I read the base 2, and then if it's to the 2nd power, then I'll just say squared. Now let's say I've got 2 to the 3rd power. Now I can always read 2, the base number, and then I tell to what power it is. 2 to the 3rd power. But whenever we have a 3, many people will say cubed. So I can read it two ways. I can say 2 to the third power, or I can say 2 cubed. When I get higher, 2 to the fourth, all I'm going to say is 2. I tell the base number, and then I tell you to what power by reading the exponent. 2 to the fourth power. There's no simple shortcut for anything above 3. So if I had 2 and a 5, this would be 2 to the fifth power. Same thing with 6. 2 to the sixth power. But whenever I have a 3 as the exponent, I can say cubed, and anytime I have a 2 as the exponent, I can say squared. Let's try a problem that uses powers. Here we have write 6 times 6 times 6 times 6 times 6 as a power. Well, I know that I've got two parts to writing a power. I have the base and I have the exponent. So let's identify the base. What number is being repeated over and over and over again? Well, that's easy. 6. Now I've got to figure out what the exponent is, this missing number that should go right there. So I know that the exponent is how many times it's being multiplied. So I count how many 6's I have. 1, 2, 1 6, 2 6, 3 6's, 4 6's, 5 6's. So that means I'm going to go to the fifth power. I just wrote this numerical expression right here as a power. 6 to the fifth power. Let's go the other way around. Write 2 to the fourth power in expanded form. So I'm going to write the base. My base is 2, and the exponent tells me how many 2's I need. I need 4 of them. So I've got 1, 2, 3, 4 2's. And I'm just going to put a times sign between each one of them. I've now just written 2 to the fourth power as an expanded form. Next, let's actually solve a problem and see how much it is actually worth. What is 3 to the third power? And what is it worth? How much is that? So, I'm going to find the value of it. I need to know what 3 to the third power looks like in expanded form. So I'm going to write it out. 3 is my base, and the exponent here tells me how many 3's I need. I need 3 of them, so I write 2 more of them. Now I have 1, 2, 3 3's. I put a multiply sign between each, and now I can find out how much this equals by multiplying the 3 3's. So if I do 3 times 3, that gets me 9. And if I do 9 times 3, that gets me a total of 27. So the value of 3 to the third power is 27. Now, be careful. A common mistake that people make is to just times the base by the exponent. That is a no-no. If I did 3, the base, times the exponent, 3, I would get 9, which is not correct. 27 is the correct answer. So make sure that you check and have it in expanded form when you do your math. Do not times the base and the exponent. Let's see if we can find the value of one more. How about we do 4 to the fourth power? So I'm going to start by writing my base, and I see that my exponent says 4. That means I need 4 of them. So I get 3 more. Now I've got 4 4's, and I can multiply them all together. I do 4 times 4 is 16. Now I do 16 times 4, and that gets me 64. Now, if I times 64 by the last 4, I'll get 256. And that is going to be the value of 4 to the 4th power. Finally, let's finish off by comparing two different powers. We're going to first look at 3 to the 2nd power compared to 2 to the 3rd power. Let's see which one is actually bigger. Now, a lot of people will just look at the base and think that automatically this particular power is going to be bigger because 3 is larger than 2. However, that might not be the case. Let's write them out. 3 2 times is 3 times 3. Let me erase that and make it look a little prettier. And 2 to the 3rd power is going to look like this. 2 times 2 times 2. Now let's do the math. 3 times 3 is going to get me 9. 2 times 2 is 4, and 4 times 2 equals 8. So in this case, 3 to the 2nd power is bigger than 2 to the 3rd power, but not by much. If this were to go to 2 to the 4th power, it would actually be bigger because 8 times 2 would get us 16. So, be careful when you're comparing two powers. Don't just look at the base. Actually solve for the value to see which one is larger and which one is smaller. Let's review the objective. Our objective today was to be able to write and solve expressions with powers. So you should be able to now know what a power is, write one, be able to write its expanded form, and solve to find the value of that power. If you can do that, then you've learned and met our objective. If you haven't, I suggest you review the video a few more times until you get the hang of it. Thanks for watching. Have a great day.